So today we're going to move on to assignment number 2 in our unit on statistics, unit 5 here in Algebra 2. We're going to be really talking about three things. We're going to be talking about outliers and what really mathematically makes an outlier. And then we're going to be talking about percentiles. How do we find specific percentiles within a data set? And then how to calculate something called weighted averages, which is really what I use to determine what your grade is in Honors Algebra 2. So let's go ahead and get started. So we're going to start by talking about extremely high or extremely low values, which we know can be considered outliers. So if we take a look at something like this, this is the length in minutes of phone calls from a certain organization. Okay, so these are not in any particular order. So sometimes it appears, or it's helpful if we could put them in order. And we can make arguments right now if we think that 10 would be considered too low of a number, or 22 maybe is considered too high of a number than compared to the other values, that we might determine that those values are considered outliers. And whether our arguments are good or not good, there is a mathematical way to determine whether or not a specific number within a data set is an outlier. And so that's what we're going to talk about today. But in order to do that, we want to think about what the numbers would look like in a box and whisker plot. And so if we were to make a box and whisker plot of this, the median value would be 12.5. This would be our Q2 value. Okay. Then we'd have our lower values, our lowest half. We would divide that in half. And so that would give us our Q1 value. Then we would take our upper half and cut that in half, and that would be our Q3 value. So in this particular example, our Q2 value would be 12.5. Our Q1 value would be 11. And our Q3 value would be 14.5 because it would be right between 14 and 15. So these are the values that would make up our box in a box and whisker plot. And those values also help us determine whether or not a specific number is considered an outlier or not. One of the numbers that's going to be really helpful, or one of the values that are going to be really helpful, is for us to find out our interquartile range. And so in this data set, our interquartile range, it's always our Q3 value minus our Q1 value. So 14.5 minus 11 is 3.5. And so that distance is always going to be important for us when determining whether or not another number is considered an outlier or not. So if we have a distance of 3.5 for our interquartile range, this is how we would determine whether a number is too small. We would start with our Q1 value, okay, and we're going to subtract 1.5 times our interquartile range. Okay, 1.5 times our interquartile range. That, if I move on this PowerPoint, that is what this equation is here. If a value is too low for us to consider it to be an outlier, we would take our Q1 value and subtract 1.5 times this distance of 3.5 that we came up with, which is our interquartile range. So to determine whether a number is too small, our Q1 value is 11. We would subtract 1.5 times 3.5. Well, that's 5.25. And if I were to take 11 minus 5.25, that's 5.75. So in other words, mathematically, in order for a number to be considered an outlier, it would have to be less than 5.75 for this data set. Well, similar formula for determining whether or not something is considered too high, okay, or could be considered an outlier because it's too high of a number. And that's going to be our Q3 value, okay, which in this case is 14.5. And then we're going to add 1.5 times our interquartile range. So in this case, we're going to take 1.5 times our interquartile range, which is 3.5, and that's 5.25. But then I would add that to 14.5. And if I take 14.5 plus 5.25, that's going to give me a value of 19.75. So if we have a number here that is bigger than 19.75, that would be considered an outlier mathematically, and 22 is higher than that, so we could consider 22 to be an outlier. These numbers here, the 19.75 is considered our upper fence, and then the 5.75 is considered a lower fence. Anything outside of the fences could be determined to be an outlier. Statisticians usually have some leeway on whether or not they actually determine that they are outliers or not. And a lot of it depends usually on whether or not whoever's doing the statistics, if it benefits their point of view or if it doesn't benefit their point of view. They would either consider it an outlier or not consider it an outlier. So let's go ahead and talk about percentiles. Percentiles is the second topic that we want to talk about in this PowerPoint, in this video. And so percentiles defined as the value at or below which a certain percentage of observations lie. There are different textbooks, different statisticians that define this in a different way. But this is the way that we're going to define it here in Math Excel and in our Honors Algebra 2 class. Anything at or below a certain percentage of values. So for example, let's say we take a look at this data set. This is the number of times that we find that a person can catch a kernel of popcorn in their mouth in a row. And so we have done, I think there are 20 numbers here. If we survey 20 people, or if we test 20 people, or maybe you do this 20 different times, and the first time you do 2 in a row, and then you do 8 in a row, and then you do 4 in a row, and then you do 11 in a row. And we keep track of this to determine how many times you can catch a kernel of popcorn in your mouth in a row. This is the number set that we would come up with. That would be a fun activity to do in class. But let's say that we want to find what number would be in the percentile ranking of 10, or what would be the percentile ranking of 10. So in other words, let's say there were 20 different people and you did 10. So what would be your percentile? Well, that percentile would be anything at or below 10. So all of these numbers here, including the 10, that's a total of 17 of the numbers. So we have 17 out of the 20 numbers. If I divide that, that's 0.85, which means that 10 would be in the 85th percentile. You guys are used to this when you guys get your SA or your ACT scores back, or SAT scores back, or even your ISTEP scores back. It usually gives you a little report, and it gives you percentiles of where you fall with everybody who's taken the test. Maybe you're in the 60th percentile or the 95th percentile. But that would include anything that is at or below how well you did on the test. And so we could do this mathematically using this formula. Okay, we take the number of values at or below x, which in our case was 17. We divided it by the total number of values, which in our case was 20, and we multiplied it times 100. And so that tells us what the percentile is at a certain number. And it wouldn't matter, like for example, take a look at this, all of these 8s here, it wouldn't matter, we wouldn't know which 8 we were talking about. So we would have to count all of them that are at or below this. So for example, it doesn't matter if I'm talking about this 8 or this 8, all the numbers that would be at or below 8 would include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's going to be 14 of the numbers out of 20, and 14 out of 20 is 70%. So if I could catch 8 in a row, well then I'd be in the 70th percentile. So let's take a look at something like this. What would be in the 25th percentile? So this time, instead of giving you the actual number, we're actually trying to find what number, if I wanted to be in the 25th percentile, what would I have to get? Well, so the 25th percentile, it must be equal to or larger than 25% of the numbers. So in this case, there are 20 numbers. So I've got to find out what is 25% of the 20 numbers. So I would take 25% of 20, which is 5. So I'm going to be looking for the 5th number. And so here's 1, 2, 3, 4. My 5th number is a 5. So anything that would be 5 or below would be considered in the 25th percentile. So it would look something like this. I would take 25% of 20, which is 5. Therefore, it should be the 5th number in our set of 20 numbers, which is a 5. So that means the 5 would be considered the 25th percentile. Now you can make an argument. You can say, well, wait a minute. If I look at this 5, that's going to be in the 35th percentile. And so because 1, 2, 3, 4, 5, 6, actually the 30th percentile, that would be the 6th number. No, 1, 2, 3, 4, 5, 6. That's the 7th number out of 20. And so 7 out of 20 is 30.35, which would be the 35th percentile. And so it's a little bit different going in one direction, okay? But I don't know that if this is my 5th number here, I didn't know that the 6th one and the 7th one were a tie. And so I would still say that in the 25th percentile, I would have a 5. So with larger data sets, to kind of avoid that problem, we would use a number something like this. Like, for example, if I wanted to find the 25th percentile, I would put 25 out of 100. So I'd have 25 out of 100, okay, which is 0.25. Then I'd multiply that times the number of numbers, which in this case is 20 plus 1. And if I take 0.25 times 21, that's going to be 5.25. So in the 25th percentile, I would have to go to the 5.25 number, which would still be 5. Let's move on. Let's take a look at weighted averages. So weighted average is this is the third topic in this assignment. And a weighted average is what I would use to calculate your grade in here. As a matter of fact, in Honors Algebra 2, 10% of your grade comes from homework. Okay, 20% of your grade comes from quizzes, and 70% of your grade comes from tests. Now that might sound like a lot, but that's what you also get to redo in class. We have the checkpoint A's and checkpoint B's, and that's a big part of your grade. As a matter of fact, you can make a good argument that the homework and the quizzes are really there to help you prepare for tests. So anyway, we use a weighted average so that the weights are always the same. We wouldn't want like 95% of your grade to come from homework and only 5% from tests. And this ensures that no matter what the point values are for our quizzes, our tests, or our homework, still 70% of your grade is going to come from tests, and 20% of your grade is going to come from quizzes, and 10% of your grade is going to come from homework. So if we're calculating a weighted average, it's going to look something like this. Suppose we have a student that they get their homework done and correct 98% of their time. So that would mean we would take 98, let me do it up here, we would take 98 times 10%. So if I do that, they could, if they were perfect on their homework, they would have 10 points from their homework. In this case, they're going to have 9.8 homework, or 9.8 points out of their total grade are going to come from their homework. Okay, because it's going to be 9.8 times 0.1. Well, suppose they are getting an 85% on their quizzes. So I would take 0.85 and I'd multiply that times 0.2. So I would take 85 times 0.2, which would give me 17. So 17 points. They could, if they got 100% on their quizzes, they could get 20 points out of 100 from their quizzes. In this case, they got 17 of those points. So if we take a look at their last category, which is their test, we would take 71 times 0.7. Okay, so I have a 71%. I'd multiply that times 0.7 because it's worth 70% of their grade, and that's a 49.7. So if they had 100% on all of their tests, they would get 70 points from their tests. Well, they only have a 71% on their tests, which means instead of 70 points, they get 49.7 points. And then if I added all of these values together, it would calculate as their final grade. And in this case, their final grade is going to be a 76.5%. So a weighted grade ensures that like if I really want the majority of their points to come from how well they do on tests, this is going to ensure that 70% of their grade comes from that category. Okay? And even though, like for example, in our class, we spend a lot of time doing our homework, okay? That's only going to be 10% of your overall grade. So even though we spend a lot of time doing it, the reason we're doing it is so that we can do well on our tests, which make up the majority of our grade. So that's how we would calculate weighted averages. Those are the 3 topics in this lesson. Hopefully this video helped, and we will see you tomorrow in class.